Okay, welcome everyone for this last afternoon session of the Digital Ocean Pavilion. Behind the scenes, we started to call this afternoon the cherry on the cake, because it is really the last moment that you can see how all of these beautiful applications were created. Many of them were showcased, but now we are targeting, well, first of all, the youth. The afternoon is called Youth Takes Action. But also, we are actually calling people to action, to really experiment with EDITO. And we are going to introduce you how we created our applications so that you can contribute yourself. So my name is Lorinc Meszaros from Deltares. I will moderate this session. And as I mentioned this afternoon, we are going to show you how to use EDITO. And specifically, this is done through the achievements of the EDITO-ModelLab's project and the hackathon that is going to be launched, and our colleagues will explain longer, but it is going to be a several months experiment where you can onboard, learn how we did our applications, and you can deploy yours as well. So let's start with the session. First of all, I would like to invite the project coordinator of EDITO-ModelLab's, Yann Drillet from Mercator Ocean International. Please introduce the project so that we have a good context and a background on the applications. Thank you.
Thank you very much, Lorinc. So yes, I will introduce this project called EDITO-ModelLab's, which is a European Horizon project. So it is a research project with a strong objective to develop together application, modeling component, and so on, to integrate that for demonstration in a common platform, which is the backbone of the digital twin of the ocean. So I'm Yann Drillet from Mercator Ocean International. So first, what is this EDITO project? So it's really to develop this platform for discovering, visualization, leveraging products, knowledge to power digital twin of the ocean. So it is really this objective to have a common framework to co-develop things and to...
There's an ocean of data.
Let's start immediately. Yes, I just want to show you a first short video which explains the main concept and how it has been developed and what is already feasible with this platform. So I'll start with this short video.
There's an ocean of data at our fingertips, but it can be a lot to handle. We need better ways to harness and share it so we can transform shared knowledge into action. EDITO is the public infrastructure for the European digital twin ocean. It offers you high-quality marine data on a cloud computing platform you can access anytime, anywhere. Whether you're using EDITO to build digital twins, contribute your own services, or explore marine data, let's see what EDITO can do for you. Imagine an environmental modeler with a mission to protect the coast from rising sea levels. Using EDITO, he can simulate different solutions, from growing seagrass meadows to restoring shellfish reefs or salt marshes. Armed with this knowledge, he can help policymakers select the best option for the future. You can also contribute your data and services to ensure lasting impact. Picture a project manager working to develop tidal energy sources. Her team has developed a new digital twin for designing tidal turbines. But what's the best way to share this tool with new users? By adding her services to EDITO, more people will access and build on this work, growing the potential of clean energy across Europe. You can also use EDITO to explore a wealth of marine data. Back on land, a marine data scientist is studying European turtle populations. But what's the best way to track their movements in the wild? With EDITO, she can access interactive data on ocean currents, water temperatures, and potential threats. EDITO grows her knowledge of what it takes for species to survive and for protecting biodiversity going forward. And that's not all EDITO has in store. As the community grows, more and more digital twins, applications and services will build a shared foundation for ocean knowledge and sustainable action. Take the leap, join EDITO and grow the European digital ocean community.
Okay.
Please clap for a beautiful video.
So yes, that's an overview of what is already feasible with EDITO and the main concept. And now we will explain how we use this platform to contribute, to deliver new product, and to develop specific application. And you can have also a nice example on the other part of the pavilion. So just a few words about the project. So this project had been submitted to the UN Decade as a UN Decade action. So it is part of an international program called EDITO for Digital Twin of the Ocean, a program in the UN Decade. And so EDITO is really the European contribution of this international program. And the EDITO-ModelLab is based on a quite small consortium with only 13 partners, with a strong skill in a large diversity of activity, including numerical modeling, supercomputing, artificial intelligence, software development, and a strong link with our international community in operational oceanography. So most of the partners are also involved in Copernicus Marine Service, for example. And there is also a lot of activity in terms of design, the application and the modeling component with the users and for the users, and science communication. So during these 2 weeks, we organized several meetings, and we talk a lot about EDITO and what has been done in the different projects. So the different components that are integrated in this platform, so new data, new models, computing services, how it is linked between the different infrastructure, and how we can define services and on-demand processing. So last week we had a specific meeting to showcase the what-if scenario that has been developed in the project. And today we will launch this hackathon for intermediate users. So it's of course for users that have some skill in terms of model development using a cloud platform and these kind of things. But we will showcase what are the applications that we have developed, what are the model components that you can use, and the objective is to engage much more people in this project and to help also new users of the platform and new users of the model. So I think that's it for me. And now
Thank you very much, Yann.
Thank you.
Yeah, so please show your appreciation for this really informative introduction into the project. But the reason why we gathered here today is actually an important event to launch an important journey. And I invite Tiago Garcia from Plus Atlantic Colab, who walk us through this hackathon. Please explain also what that means and what we can expect from it. And then, please, for all those people who like beautiful videos, we have many more. So please bear with us.
Indeed, we have amazing stuff to show you this afternoon. So thank you all for being here. Thank you, Yann, for this introduction to what is the European Digital Twin Ocean and how this project, EDITO-ModelLab, contributes to its construction. Now it's time to welcome you at the hackathon of EDITO-ModelLab. So as Lorinc was just saying, you may be familiar with the term hackathon. Most of the time, a hackathon is a very concentrated experience in which people, in a couple of days, most of the time, they are given a challenge and they have to come up with a solution. So that's the, let's say, the most common concept of a hackathon. This is a special project, so our hackathon is also special. It's not going to last a few days, it's going to last a few months. It's starting now, today it's the official launch, and it's go on throughout the summer until late September, October. And what is exactly our hackathon? So, as Yann was just saying, we have what we call the intermediate users. Who are these people? So we're talking about model developers, people who use numerical models, data scientists, among other people who have, as Yann said, some skills to program, to code, to download data, to process data, et cetera, et cetera, et cetera. That's what we call the intermediate users. And with the hackathon, we want to train them and give them a chance to start working with the EDITO platform, which is one of the key outputs of this project. They will have the chance to explore all the components that already exist in the EDITO platform, and you will learn about this more. And with that, they will have also the chance to create their own applications for their own problems, for their own work, for their own communities. So if you don't know, the EDITO platform and the European Digital Twin Ocean already have some applications there. You can have a look in the next room, for example. And we're giving a chance to people to go beyond this and to use it for their own needs, if they are not covered yet by what the digital twin already had. And with this, obviously, they will be contributing to the construction of this amazing initiative, which is the European Digital Twin of the Ocean. So what do we aim to achieve with this? I think it's almost obvious, but let's go through it. We want, first of all, we want to connect these communities, the communities that develop these tools and the communities that use these tools. So the goal is obvious. We don't want this to be a tool that some people develop and nobody uses. That's not the purpose. We want the real people dealing with the real world problems to use it. Of course, training is needed. So that's what we are here for. We will be training these people, let's say those who have the skills to program and to code. We're going to train them to use all the potential of the EDITO. And with this, as I said before, they will be in a great position to contribute, to further expand an EDITO, to add more value to it. And of course, while they do this, they will be in touch with us. It's going to be a two-way communication. We're going to get feedback. They're going to get mentorship, as I will explain you, and we're going to get feedback to improve what we already have even more. So what's going to happen is today it's kind of theoretical. Nobody has to do anything. It's just an introduction. And you will hear after me, you'll see a lot of focus applications of EDITO that already exist. These have been developed and validated in the last few years, and they are now ready to be used. But we want to go beyond that. So in July, or this month first, this month we're going to invite people to be part of the hackathon. And we're also opening this to someone else that thinks he or she has the skills needed to join this initiative. And if you are one of those, if you are here in the room or if you are online watching us and you would like to be part of this, you can join us. So just let us know. Go to our website. There's an email there, and you can tell us that you're interested. So what's going to happen after July, once we have the group consolidated, there will be modules that people will receive from their mentors, almost like on a weekly or two-week basis. This is still yet to be finalized. And they're going to go through all the components. They're going to see how everything works right in the engine of it. Not the end result of it, because that's for the end users, but the really mechanics behind the machine. And they're going to go through this as a sequence, a hands-on initiative where everybody will have the chance to really work with it and see how it runs, what can be done with it, and so on. This will take place online, and in case you're wondering, why are we doing this in summertime? It's okay. You're not going to be bothered. If you have vacations, you can still do them. If you want to go to the beach, you can still go to the beach. All of this is compatible to your plans and to your personal life, and it's going to be an amazing experience. And you will have a mentor. Anyone involved will be guided by the people in EDITO-ModelLab to go through all these modules one by one until the end of September. And then finally, in October, we will have a final event where the participants are going to show us the applications that they developed during the hackathon to further expand the potential and the added value of the digital twin. So this is pretty much what's going to happen. We were now going to start seeing the already existing focus applications. And the goal of the hackathon is that the participants can develop other focus applications or even refine these ones. So thank you very much. And if you're interested, just let us know, and we will do our best to have you joining the hackathon. Thank you very much.
Thank you, Tiago. I think you forgot to mention one important thing, which is the European Ocean Pact that was actually that has started and was endorsed during this ocean conference. And that has one specific pillar on European research and innovation, and that specifically mentions EDITO, the European Digital Twin Ocean. So that is just a stamp that EDITO is going to stay in the European policy marine information development for a long time. So what you are witnessing now is as a first glimpse at what will the future hold. So now we are transitioning towards the content, which is my favorite part, and that is giving you more insights on what are the underlying components and how they can be reused. And the term focus application summarizes the nature of these applications that are on building blocks and targeting focus areas. It can be, for example, biodiversity, shipping, or oil spill, as we will see this afternoon. So Yann has already shown the different components. Everything starts with data. Obviously, a huge data lake is being used here. And sorry, it's a disclaimer that there are some numerical terms and more jargon from the digital and modeling society here, so I will try to avoid those. The second, obviously, we need a range of models. All kinds of models, from community to coastal, applied models. All of these are really necessary to produce what-if scenarios. Then, obviously, we cannot produce anything without sufficient computing resources. EDITO guarantees that. And on top of these, we have digital services developed, and including some of those, allow you to replicate and model in new areas. So let me give you an example of each. First of all, the data sets. The EDITO data lake is built on Copernicus Marine and eModNet, including all of their observations and model products. But what I find even more powerful is that whenever you set up a new application and you validate it, and the community gives a stamp to it, this can also be added to the data lake. That means regionally and a local level, more and more of these applications and data sources will be added to it. And that allows us to grow together. Second, obviously, the models. We started as in EDITO-ModelLab's consortium with the most trusted and best-known European models for ocean and coastal processes. But that's not enough to stop at physics, to stop at basic variables. So that's why we added models for biodiversity or marine protected area quantification, for ship routing and oil spills, also for microplastics. You will see some of them in action this afternoon. And then, obviously, the computing resources are also European. When it's about cloud computing, is the Wikio service. And high-performance computing comes from the European high-performing computer centers, EuroHPC, and we are making direct connections to them. All of this is in this beautiful, innovative, and user-centric platform becomes kind of like a web shop. I think you all know web shops where you can just pick and choose. That's exactly the idea here. So what you see here is different components. You want to run an ocean model, a coastal model. You want to build something in front or post-process. You just pick and choose, combine them in a workflow, and that way you can come up with your own local digital twins. And obviously, importantly, many areas around the world don't have valid data at the moment. Those can be simulated with the processes that EDITO has. So that was it in terms of basic introduction. What I wanted to add is that many of these applications already have nice tutorials. This is, for example, the application of our colleagues from CMCC. These tutorials are completely open. Everyone can go and discover. It walks you through the application, how to launch it, how to manage it, how to replicate them. And we try to make it self-explanatory, and it's an online resource. So that's all about the basics. And right now, we are transitioning into 3 use cases, 3 focus applications. I myself will explain a tool that can help identify habitat suitability maps that in turn helps marine protected areas and biodiversity conservation. My colleague Mario will explain how shipping can be made more greener and with optimize the routing of ship routes. And finally, Igor, also a colleague from CMCC, is going to explain an oil spill case. So let's begin with mine. We are now transitioning a bit towards the North Sea. My Institute Deltares from there. And we have marine protected areas related to, for example, in the Wadensee, where seagrass is an important habitat species, and that's why you see that on the screen. So instead of me explaining the background of this application,
sustainability mapping
please listen to this video.
by EDITO-ModelLab's. Countries worldwide aim to protect 30% of land and sea by 2030. Deciding where to create marine protected areas, or MPAs, is crucial. MPAs safeguard places where environmental conditions support rich ecosystems. But to choose the right areas, we need a deep understanding of the ocean. This understanding comes from real-world observations and computer simulations. However, these tools are often complex, costly, and hard to access. The European Digital Twin Ocean, powered by EDITO-ModelLab, changes that. It provides free access to ocean data and advanced tools for simulation. With the EDITO platform, you can use modular tools to create habitat maps. No installation is required, as everything runs on EDITO's cloud system. This makes the platform easily accessible for a wide range of stakeholders. Let's look at an example in the Dutch Waddenzee. We'll simulate how marine species respond to their environment. We define species' ecological needs and environmental factors. Then, we run a simulation right from the cloud. EDITO then produces a habitat sustainability map. This helps us identify the best locations for marine protection. With the European Digital Twin Ocean, scientists, policymakers, and communities can make informed decisions. Learn how EDITO-ModelLab makes ocean knowledge accessible, empowering all to protect marine life and achieve sustainability goals.
So this was obviously a bit of marketing video to summarize you what exactly you can expect from an application like that. But I thought that you also deserve to know more, and that's why I will go one step deeper. And I will show you how this workflow is functioning. The one that you have seen from generating data layers, adding environmental knowledge, and then produce habitat suitability maps. So here is the first step. We work with components that rely on, in our case, on our coastal models and ecological impact models. We use EDITO data lake data, AModNet bathymetry, and initial and open boundary conditions from Copernicus Marine. We make use at the moment of the cloud computing capacities. And we also use and published pre- and post-processing components that you can also yourself use. And finally, we have actual model simulations, and they are also published. So the first step is to set up a model somewhere. This is an example on how you can find our so-called model builder and launch a service. The platform itself allows you to also store secrets and API configuration files. So that means if you connect to something else, you can do that privately. And basically, everything is self-contained, and you can store it in your project. So once you configure your account, you can just pick a component and launch it. In this case, the component will be more on a Jupyter notebook base. It's a bit more technical, but that allows flexibility. You can just give a model a name, this Delf3D model. You can choose 2 or 3D. You find a bounding box domain, a target resolution, and the simulation period. And then step by step, everything will be generated for you. Obviously, the first thing that you do is you have a grid. In this case, an automatically growing flexible mesh. You also take the bathymetry, either local or globally available. Then you get your boundaries and initial conditions that you will see are much coarser than our locally refined model. You also need meteorology. You have to force that, and that we also get from a European service. And then, once you have that, you can also pick locations to extract information from your model. These are so-called observation points. And finally, you generate everything into one model definition file. And if you visualize that, you get a full model tree, which used to take a good couple of weeks. Now you can do that even right now or from your laptop in a few, well, I would say hours. So once you set up a model, this is stored in your file system. So you see I finalized this process. I go to my files. They are in the Del3D-FM inputs. And now I can start to simulate. So now I go back to the processes library or catalog, and I choose the appropriate model under ocean modeling and launch it. Obviously, case-by-case basis, we need different resources. You are allowed to change resources. And once you are done with that, basically, you can just, you will see this changes the platform, obviously. But once you are done with that, you click launch, and the process is dispatched either to a cloud computing or high-performance computing. You are informed on what's happening. You can monitor the process. And finally, you will see, hopefully, that it's a successful simulation. And you can also monitor your quotas, your GPUs, your memory, and storage usage. It was successful, and you can go back to your files, and you see that there has been now Del3D-FM output. So now you are done with your modeling first step, actually the second already. And once you have that, obviously, you could repeat it for other variables. You can do salinity, you can do pollution, you can do inundation. Once you have those layers, you can add through other services and through local ecological knowledge, you can translate the physical conditions that you have been simulating to habitat suitability. And when you put that together, that's when you get the final habitat suitability maps, in this case, meant for seagrass. So that is the full workflow that I wanted to show you. I can assure you the rest of the presentations will be much more high level. But I wanted to see you once how it really works. It is not just the beautiful globe. It is really a lot of processes and technology behind it. So just to summarize for my case, I think this application that we have deployed, it is really valuable because it applies to the entire global coast. You could launch this anywhere because thanks to the Copernicus Marine global boundaries, we can simulate locally anywhere. It is also, it can be applied to any species. You can replace seagrass with mangroves, as our Indonesian colleagues did, or any other species, as long as you know the knowledge curves. And therefore, you can locally change your protected areas, not only based on scarce data or global models. And this obviously contributes to biodiversity protection and restoration. So that was it for me. And I would like to ask now Mario to come to the stage. Mario Salinas from CMCC, Italy. Please introduce the ship routing application. Thank you.
Thank you. Thank you, Lorenz, for this great introduction and presentation. And yeah, we'll just go by these slides. And previously, I want to thank you also, the other main contributor of this work, Gianandrea Manarini, that unfortunately couldn't be here today. So we are going to talk about this focus application number 2 about ship routing. But first of all, a couple of words of why this could be important. We know that ship routing alone contributes for about 3% of global emissions globally. So it's indeed some non-negligible contribution, I will say. And in fact, we need some short-term measures to, let's say, lower the impact of this kind of transportation over the global, let's say, global emissions. And one of them could be ship routing. So the main model components that we used is obviously our Vizier 2 model, that is an open source graph-based ship weather routing model that has been deployed in a containerized way in the EDITO platform. Then, as data, we leverage on Copernicus Marine Service data, specifically waves and ocean currents, but we can also exploit a product directly from the EDITO platform, that is the UGlobe waves product. Then, as computing resources, we leverage on the cloud platform, just for now. And the name of the service that we published is the Pacific Green Corridor, and we will see why. There's a reason behind this name. And all of this is served as an on-demand processing, so every user, upon registering on the EDITO platform, can run a list CO2 route anywhere in the Northern Pacific. Okay, so in a nutshell, we are going to see these ship weather routing services powered by our open source Vizier 2 model. By the way, you can find all the details of this model online if you search for it. And this is a model capable of integrating information coming from currents and waves, combining them and exploiting them to provide the users with optimal ship routes, optimal with respect to CO2 consumption in this case. And does this by leveraging on Copernicus and also on uGlobe product. Okay, so I think that we can see an example of a route in action. This, you can see, is the final output of our model. Then you can launch simply by clicking on a button and selecting a brief list of parameters, as we will see later on. And we named this service the Pacific Green Corridor because we decided to instantiate it on this particular sector of the global ocean that will be named in this way, Pacific Green Corridor of Shipping, because there will be a lot of initiatives from the next years aiming to decarbonize shipping in that particular area of the global ocean. We focused on the northern Pacific portion and specifically on the Shanghai-Los Angeles corridor, but you can compute in principle a route between any 2 points in this domain. So basically, we enable a North Pacific on-demand route computation in this way. Okay, this is an example of what can be done with this kind of model. And this are some of the results that we recently presented at the EGU 25 conference. Basically, we computed a climatology of routes, about 2,000 routes, sorry, and all over the 2024 year and over the Northern Pacific domain. Besides all the technical details of this image, because, for example, we can see that in the upper part of the panel, the routes is trying to exploit the Kurosho current below Japan, but it's some technical detail. In this work, we try to assess the sensitivity of CO2 emission from the shipping sector to various factors like seasonality, forcings, route orientation, and also speed optimization in a way. And what we found is that just for this single route, for the Shanghai-Los Angeles routes, there are savings possible for ranging from 10K to 40K tons of CO2 just for a yearly route, for a single route. So I would say this can be a really good short measure to limit also to the impact of and also to decarbonize the shipping sector. Okay, then we have a video, and I think there's also a voiceover, so I won't need to talk. Let's see.
Pacific Green Corridor provides optimized ship routes as part of the European digital twin of the ocean. It leverages open source Vizier 2 ship routing model. The application is containerized via Docker, delivering a ready-to-use solution directly to end users. To request an optimized route, open the service from the data lab and provides routes departure and arrival locations, routes departure date and time, environmental fields to be used in the simulation. In this example, the ship departs from the port of Shanghai to sail to Los Angeles. The blue line represents the shortest route in terms of distance sailed, while the green line shows the least CO2 routes. Such a diversion is necessary to avoid rough seas, allowing the ship to maintain higher speeds and reduce overall CO2 emissions. Once the simulation is finished, it produces a zip file with the results. It contains the requested optimized route, some metrics, and a map rendering. The Pacific Green Corridor is an open decision support system developed to showcase the potential of the European digital twin of the ocean in tackling societal challenges. We actively welcome collaboration with end users to enhance its realism and usability.
So let's go on to the take-home messages. So I think that in this way we demonstrated that the EDITO platform can be used to develop and deliver also user-friendly and on-demand service, in this case about ship weather routing. And also leveraging on the EDITO platform, this simulation can be launched and analyzed from any device, basically also from your mobile phone. And also this kind of application in particular demonstrates the relationship that it is between the CO2 emissions and maritime and environmental conditions, gaining up to 2-digit emission savings. So I think it's all for me. Yeah. Thank you.
Thank you very much, Mario. And with this, we transition to the last example, because it's becoming heavy, a lot of technical details, but unfortunately, that was planned. We are reaching out to really people who want to understand this, want to reproduce it, and really integrate into EDITO. And with this, I would like to give the word to Igor, and please introduce us to your oil spill simulation.
Good afternoon, everyone. So I think I'm the last today. And now I'm talking about oil spills, which are unfortunately still a reality. So that's why I start with this image, which is an example captured by Copernicus satellites, where we have the oil spill that happened in Syria in 2021. So it's a very huge accident that happened due to lack of maintenance in the area due to the civil war. And then we can see this huge impact leaving from Syria up to the northern part of the Levantine basin in the eastern Mediterranean. So I'll be exploring the focus applications, showing a little bit about this case and how you can do an oil spill simulation based on what you have. So to start with, for our focus application, we call it With Oil Cloud. Basically, you can use Meszaros, which is an open source community oil spill model, on the platform. We designed it to be a user-oriented platform, so even non-expert modelers can use the application and launch oil spill simulations from anywhere. In that case, I use an example in the Taranto Bay in the south of Italy, so you can launch a simulation, even if it's hypothetical, to allow people that are interested to assess the impact, even if you just like to see what would happen if an oil spill happens in my region. So, as I said before, you can choose anywhere in the world, either Mediterranean, global sea. That is all being done by the backend of the application, so you don't need to know the details of what is going on. So here in the next page, I show the results. Either if you launch simulation in the Taranto Bay, what happens, what are the currents, more or less in that moment. And all of this data is not necessary to be loaded by the user. As Lorinc, Yann, Mario mentioned, all of that is already not necessarily within the platform, but with your credentials, you can use the data that is available online. So here we are using the Copernicus marine currents for the Mediterranean Sea and the winds from Area 5. And the results can be checked even within the platform itself. So here, last video of the day, I think so, and I'll show more or less what happens in the example I mentioned.
To start, go to the service catalog on the left-hand side. Then, search for Focus Applications and click on Launch on the WeTool Cloud Card and click again on the Launch button. The service will be downloaded for you. Now launch the WeTool Cloud. Now you are in the WeToil Cloud landing page. To perform the simulation, go to the left-hand side panel and click on the WeToil simulation. Once the map is loaded, scroll to any position you would like. Here, we are scrolling to the approximate location of an oil spill that happened in Syria back in 2021. Once the location is set, click on the pin in the map and select the location. Now we can select the date and hour of the event. We can also modify simulation length. In this case, it will be 96 hours. If more than one dataset is available, you can choose it. It is possible to modify the oil API, a density approximation. It is necessary to insert the volume of oil in tons. And now the amount of time oil is released. 0 for instantaneous, otherwise number of hours. Now you should insert your Copernicus account details and ECMWF token to download data on the fly. Give your simulation a name and then you can launch your simulation. Now you just need to wait until it is finished. You can follow logs in the service page, clicking in the service name. To access results, click on the left-hand side panel. Now you have the results available. You can use the slider to select different moments of the simulation and scroll the map zooming in or out. You can check the mass balance for the given time step. And finally, an animation of the entire simulation is presented as a GIF.
So that was basically it for this example in the Syria oil spill simulation. So we were able to launch in a few click of buttons and numbers that event that was a tragedy, and that is possible to be done in other parts of the planet as well. So to finalize, the take-home messages for your application is we wanted and tried to make it as user-friendly as possible and on-demand, so we can choose anywhere in the world, anytime. The simulations, also mentioned by the others, can be launched even from the smartphone because all the computation is being done in the cloud. So the user doesn't need to worry about is my computation enough for that, my computer result. No, you can't do that. I think the important thing that we targeted is that different stakeholders can do simulations without knowing how to do numerical simulations. So this allows people that are usually not in touch with models to try for their own, even if it's just for information or just to understand. And of course, we also can support technical insights for people that want to do their simulations for themselves, or even try to make it a very ad hoc case. So that is all available within the EDITO ecosystem. And that's me. Thank you all.
Thank you, Igor. So I would just like to wrap up because it was really a lot to take. We are actually on time. But what is really the take-home message from all of these applications, all of these technical demonstrations? We just listed a couple of things really from real-life experience. What we have seen in previous projects and previous experience is that there was really a high threshold to start to produce data, a high threshold for numerical modeling. And that comes with the technical skills, obviously. You always need the technical skills. You need good researchers, good scientists. That will not change. And hopefully it will never change, even with the AI. But there are also the tools. Many of the tools we work in different countries are licensed. They are not accessible. You have to download them. You have to install them. Also, the computational resources are limited. When I started my PhD in a Mediterranean project, we started purchasing computer per local research center to simulate something. We also had financial resource issues because of the time that goes into setting up these models instead of really looking at them, how to calibrate, how to make them scientifically valid. So these were the things that I think EDITO-ModelLab really helped to change. First of all, because we didn't make numerical modeling easy, but we definitely made it much easier than before. You saw all those processes. I was proud to try that out on several students in our research institute, also in different continents. They really can set up many things quickly. And then, of course, you have to guarantee that they know that it's a first one, and you have to improve it. Anyone can use this, and it's really free, and that should remain free, because it's a European Commission initiative. It is based on supercomputing of the European Union. I just heard that we got 1.5 petabyte of data storage and many hours of computing. And all of this simply accelerates workflow, so we can focus on what matters, on looking at the results, creating more, and join and build on each other. So that was it. If you really want to know more, probably not right now, but back home, you can scan this QR code. Tiago wrote a really nice piece of newsletter, and this even gives more societal relevance to these applications. So thank you very much. It is not in the program, but I really would like to take questions if there are. And for the online participants, the several hundreds I heard, then they can always go to the Slido. They cannot call in and ask questions. So thank you very much. And if you have any questions, I will ask our team to sit here and answer. Thank you. Yann? Yeah, I will start here and then go to the back. Could you please come here and does it work?
I just have a quick question about the green corridor. I'm wondering if there's a way to calculate the amount of time it takes to ship, because what I'm wondering from a transporter's point of view, which is to save money, you're saving fuel, I imagine, by taking the low CO2 route, but you might not be saving time. So I'm just interested in how that works.
In reality, these two things in this example are coupled, in a sense that in that example, we managed to save both emissions and also time. So the route that I was showing was saving up to 10% of CO2 with respect to the least distance one, and also the same amount of time. So, but this usually depends on the vessel that you are modeling, how it responds to the waves and environmental fields. But yeah, we compute time, distance, and CO2, and yeah, that's it. Yeah, exactly. We have a model for, in that case, we have both a bulk carrier and also a 300-meter container. So we model these two kind of vessels. And yeah, so time is also taken into account. I hope this answers.
Thank you. Now I walk to the back.
Yeah, very cool applications all. I'm very excited also to work more with this. But I wondered, are there also special provisions for teaching and for using this in classrooms, for example, in master or even bachelor education? Are you thinking about how to deploy this in a more teaching style settings?
So yes, I can just say that there is already a lot of information on the EDITO website. For each application, we have really a tutorial, and that could be used for teaching. And then we will organize during the next months a specific session to explain how we can use different components and so on. So I think that all this material could be used really for teaching at any level.
Yeah, maybe I can add that just for the resources, that of course that's an issue. So at the moment we are onboarding people on invitation basis. On the EDITO website you can already request an account. Yeah. But the hackathon process actually will be also explained, and maybe I invite the UltraHack colleagues also to comment on it and maybe elaborate. Yeah.
Yeah, no, so I think that, like you heard in the introduction, that it will be a longer process now, because normally when you talk about hackathons, they last for only 48 hours. And of course, everybody can understand that there isn't that much time. And now in this EDITO-ModelLab hackathon, we are basically offering a very long runway for the development. So now we talk for months. And I think that one key factor also to make hackathons really successful is also the quality of the support. And now I think that the EDITO model team has brought the best experts on the field who understand the platform, but also the business side of it, can support the teams that will be then joining the hackathon. So it will be a bit more different, like you heard, but I think that it will be a great platform to build those new, cool, innovative applications that then anybody can use in the future.
Hi guys. Yeah, thanks for all of the detail. Looks like an amazing platform. I'm actually a beta tester. I work for a company in Portugal, and we're developing some local digital twins. So I have two questions. I saw there you have somewhere where you can store your API keys and such. Does that mean that there will be a full IDE environment inside EDITO? And also, will there be a code repository inside the platform as well? And then the second question is, if somebody does build an application, how confident can we be that that's going to persist for many years if it becomes like, quite critical?
Not sure I get exactly the question. Do you want to answer, Lorinc? Because
yeah,
there's a lot of technical.
The first answer is that we are not the best people to answer. We are basically ourselves users of the EDITO platform. And there is another project called EDITO Infrastructure, or now in the second phase it's called EDITO 2. And they are building the whole infrastructure, including security part, storage part, computation. So they can answer you. For sure, we have raised this and they are tackling it. I cannot say that every issue is at the moment completely solved. But this is definitely on the list. That's why they really created projects. And I know that you can make everything private, also for some commercial data or that cannot be shared, and some can be public. But on the security issues, I don't think I have more comments, but maybe on...
No, I don't have more detail, but yes, that's really the objective. It's still under development, this platform, and we will improve it, but for sure it's feasible to use it only for you, just for your application, and there is no obligation to share everything. So it's just... we have the capability to integrate the new things. And in the EDITO project, we already tried the different components and the facilities to share new data set, for example, to share code and so on. But clearly, it is also feasible to have your own working space just for you or for your group or for your project. And then we will define in the following months also more precise rules, especially to disseminate in a large community all the new models, the new tools, the new product, and so on. Just because we don't want to put anything available for everyone also in this kind of platform. It's not the objective.
Thank you. Any last question before we make space for even younger people? Because youth takes action after this session. If not, you can always reach out, well, on this Slido as well, but obviously if you walk around, this whole pavilion is called DigitalOcean Pavilion, so you will find many people who can help you and answer questions. Thank you very much for your attention. Camilo, you wanted to say something?
Yeah, thanks, Lorinc. Just one last thing. The hackathon is not open for free registration because we have limitations of computational resources. But if any of you is interested in joining this initiative, you can send us an email because we still have some room for new members to join the platform and the hackathon. So don't hesitate to send us an email and we will invite you to the hackathon.
Good. Thank you very much.